In this video, we want to see whether this series is absolutely convergent or conditionally convergent. So first, let's look at just this series. We see that the series is alternating because we have a -1 raised to the n+1st term. The sequence that is inside the sum, excluding the -1 to the n+1, is this, and clearly this is decreasing because the denominator is getting bigger and bigger, so the whole thing is getting smaller. And now if you take the limit as n approaches infinity, the denominator gets really big, the numerator is just 1 over really big numbers just approaching 0. So by the alternating series test, the series converges. Now let's consider taking the sum of the absolute value of the sequence. When you take the absolute value, the -1 to the n+1 goes away because now it's positive. And now we're going to compare the inside with something that is bigger. Well, you find something bigger by making the denominator smaller. And I just removed the n+4 term. Clearly, this sequence is bigger because the denominator is smaller. And n+4 is greater than 1, so whenever you take a number and multiply it by something greater than 1, it's going to be bigger. So that's why this is bigger. And 1/3 to the n power is just the same thing as 2/3 to the n power. Now we know that the sum from n equals 1 to infinity of 2/3 to the n power converges because it's a geometric series with the ratio as 2/3. So you want the absolute value of r to be less than 1 in order for the series to converge. And so by the direct comparison test, so does this sum. So this series also converges. So now we showed that both the original series and the one taking the absolute value converges. So we say that the series converges absolutely. Now instead of going through this trouble, we could have started with this slide right here and shown that since the sum of the absolute value of the sequence converges, automatically we can say that this series converges absolutely. So the first slide was really unnecessary, but I just want to do that to show you for practice.